Hello students, and welcome to Edubbey Global Solution. Again, we're going to be looking at another topic in our mathematics class, which is differentiations and gradient function. And in this class, we have a prepared interactive content that will serve as a guide for our class. Okay, and when you're talking about differentiation, the very first thing that we need to know is a derivative or a gradient function. How do we derive our functions for calculation? So the fundamental tools of differential calculus, which is differentiation, is derivative or the gradient function. That is the basic tool that we need when we are differentiating. Now, when you're talking about derivative defines the ratio of the change in the value of a function to the change in the dependent variable. So, when you are dealing with derivative, it has to do with what? Ratio of change. Now, the derivative of y with respect to x is expressed as we have the y dx, where y here is the function and the x is the independent variable. So now let's look at gradient of a straight line. That for differentiation to come into place, then we need to know how to go about derivative and gradient function. Now, the gradient of a straight line. The gradient of a line passes through point x1, y1, and x2, y2 is calculated by what? y2 minus y1 divided by x2 minus x1. So if you want to calculate the gradient of a line that passes through a specific point, it is calculated by having a coordinate of y's divided by the coordinate of x. That is our y-axis and our x-axis on the graph. Now we have a given graph here. Let's look at this graph. Okay. Now if you look at this graph, we have already drawn a what? We have a gradient point here. So we have x1 and x2 and y1 and y2. So for this one, q is going to be taking the value of s2 and y2. You see that it's actually bigger than this, and p is going to be taking the coefficient of y1 and x1. So from here now, x1 is 1, x2 is 5, x2 is 11, and y2 is here is what? Is 10. So now let's bring in the formula for calculating gradient of the function of a line, and let's see how we can calculate that. So we have told us that the gradient is given as y2 minus y1 over x2 minus x1. Now from there, y2 is 10, so and y1 is what? 5, okay? x2 is what? x2 is 11, and x1 is what? 1. So it's going to be what? 5 over 10. 5 can go in 10 how many times? That is 1. So we have 1 here. And 5 can go in 10 how many times? That is 2. So we have an answer to be what? 1 over 2. With this, we are going to be dragging in the right answer to the boxes. So the formula for calculating gradient is y2 minus y1 divided by what? S2 minus x1. Okay. Now, we have told us that 10 minus 5 will give us what? 5, and 11 minus 1 will give us what? 10. So we have 5 over 10, and that gives us the arrangement for that activity. Okay, now let's look at the gradient of the curve. The gradient of the curve is not constant, and for it to be calculated, we have to draw a tangent of points from that graph. Now we have a curve here. So from here, we have already drawn a tangent from this graph. So Q2 is what? Q2 is 2, 4, where our x2 is 2 and y2 is 4. And P is what? 1, 1. X1 is 1. Y1 is 1. So we use the formula for calculating gradient, which is y2 minus y1 divided by x2 minus x1. We can actually say change in y divided by change in x. So y2 minus y1 divided by x2 minus x1, right? So y2 here is what? Y2 is here is 4, and y1 is 1, so we have 4 minus 1. X2 here is what? 2 minus 1. So 4 minus 1, that is what? 3, right? 3 divided by 1. 3, how many times can 1 go in 3? That is 3. And that gives us the solution to the problem. Let's arrange to the right full boxes. 4 minus 1 will give us 3, right? 2 minus 1 will give us 2, so we have 3 over 1. How many times can 1 goes in 3? That is 3. So we have 3 as our final answer. So now, having that, we can check and we say that we are right. Now, let's look at what we have, which is gradient function. For a gradient function, it means that we have a change in y divided by change in x. So if our y is x plus h, function of f of h minus f of x, then our change in x is x plus h minus x. So if you look at this now, we can actually, we've opened the bracket of the denominator, right? X plus h minus x. X minus x will give us 0, right? So we have our h left here. So the slope can be calculated as function of x plus h in brackets minus f of x divided by h. Now, look at this. Under the first principle, we said that our h tends to 0. And what are we talking about first principle? We are talking about differentiating the very first time. Now, let's look at a given function here. We have to calculate the gradient of this function. So we are going to be using the formula for the slope that we have there, which is change in y divided by change in x. So what is change in y divided by change in x? That is what is going to be f(x plus h) into bracket minus f of x, everything divided by what? Divided by h. Now, from this graph here, we have told us that we have h1 plus h to be x2, 1 plus h all square to be y2, right? And for this one, 1 is s1 and 1 is s2. So if you are making use of the formula, which is y2 minus y1 divided by s2 minus x1. Now, from here, what is y2? Y2 is 1 plus, we have 1 plus h all square, okay? Y1 is what? 1, so we have minus 1 all over. What is x2? x2 is 1 plus h, isn't it? And we have it minus 1. Now, let's open the brackets. 1 plus h all square will be 1 plus h, close the brackets, 1 plus h, we have minus 1. Remember that we have this is 1 minus 1 plus h. Now, let's open these brackets. 1 times 1 will give us 1. We are using 1 plus h to multiply 1 plus h. 1 times h will give us plus h. 1 h times 1 will give us plus h. And h times h will give us h square minus 1. All divided by 1 minus 1 here is 0. So we have h left here. Okay. Now, having that, we are looking at 1 minus 1 here will give us what? 0. So we have plus h plus 8, that is plus 2h. So we have our answer to be 2h plus h square all over h, right? Now, if you look at it, h is common to the numerator, so we bring it out. So we have h equals to 2 plus h over h. So h cancels h. Now, remember, based on the change of the gradient function that we said that our limit of h tends to 0. So if we place our limit of when h is tending to 0 into this place, so that implies that wherever you see h now, h will be replaced with what? 0. So it will now be 2 plus 0. 2 plus 0 will give us what? That is 2. And that gives us the solution to that equation. Now, let's look at the next example here. We are going to be using the formula for the first principle, or which is change in y divided by change in x. And we are using that to solve this question. From the first principle, the gradient function of f of x is what? S squared plus h. So we are to calculate the gradient using the first principle formula, which is the y over the x equals to what? Lim h tends to 0, which is what? F of x plus h minus what? F of x in brackets. Okay, divided by what? We are dividing by h. because we have actually factorized. Now from here, our f of x is what? S square plus x. So that implies that for this function here, is going to be what? S is going to be taking the value of s plus h. So we have lim h tends to 0. So we have our function now to be x plus h. Remember, we are dealing with what? We are dealing with square. That's when s equals to s plus h. So for this function here, s square is what? S plus h. Okay, now we have it will be plus s plus h. We have read that in bracket. Now, what is f of s? F of s is s square plus x. All of it we are dividing it by 8. So let's open the bracket. If you open the bracket, don't forget that we have our lim function. So we are going to be using that at the latter part of the solution. So let's open that bracket. We have s plus h. Okay, s plus h. Then we have plus x plus h. Now we have minus. Let's use this minus to open what we have inside this bracket. Now, minus, this is going to give us minus h square. Minus times plus will give us what? Minus x. So everything divided by h. Now, x times x will give us s square, right? X multiplied by h, that is hx. H multiplied by s with hx. Okay, h multiplied by h, that is h square. And we still have our plus h plus x minus s square minus s. We are dividing everything by h. Now let's look at this. S square minus s square, that is 0, right? Okay, plus hs plus hs, that is plus 2sh or hs, right? Anyone? We have plus h square, okay? A square, right? We have plus h. Okay, now let's look at it again. Plus x minus x, that will give us 0. So all of this is divided by h. If you look at this, h is common to all of them. So let the numerator, so let's bring h out. So we have h into bracket 2x, okay, plus we have 1h left here and we have 1. All divided by h. This h that is the numerator and the one in the denominator, let it cancel each other. So we have what left here? We have 2s plus h plus 1. Remember, we are having a lim function as s. H tends to 0. So that implies that wherever you see h, you are replacing it with what? 0. So we can now have it to be 2x plus 0 plus 1. So we have 2x plus 1. And that is the gradient of that function, f of s, x squared plus x. So that is the gradient of the function. Okay, now let's look at polynomial function. There is a relationship between polynomial functions and its gradient functions. So if you want to differentiate using the first principle, the formula is what we have here. We have dy over the a equals to n. We have a n x raised to power n minus 1, and that is the formula for differentiating the very first time when we have a polynomial function or a gradient function. So that's our differentiating formula, which is the y over the s equals to a n x n raised minus 1. So if you have that now, we have to use this to calculate the gradient of this function. The gradient of the function is 2x raised to power 3. So let's calculate the gradient of that function with that formula, which is the y dx. That's how we call it the y dx equals to the y dx equals a n x n minus 1. Where this is the power, a is the coefficient before x, and we have our power to be minus 1. So if you have a function here which is f of x equals to 2x raised to power 3, here a is going to be 2, right? N is going to be is going to be 3. So let's use that formula. Now let's come here. We have the y over the s equals to a is what? 2, right? Okay, what is n? We said n is 3, so we are multiplying by 3. X 3 minus 1. Now if we have that, so it's going to be 2 times 6, 2 times 3 is what? 6, okay? So 3 minus 1 is what? That's 2. So we have 6x raised to power 2. That's the first one. we have the second gradient function here, which is y equals to 6x raised to power 4. We are using that formula. So from here, the formula for differentiating the very first time, which is the y over the x, equals to a n x n minus 1. A is going to be 6 here, and n is going to be 4. So we put that inside this formula and we differentiate. So we have the y over the x equals to, that implies that we are differentiating y with what? With respect to x. So we have 6 multiplied by 4, x 4 minus 1. So we have 6 times 4 is what? 6 times 4 is 24, right? So, okay, 4 minus 1, that is 3. So we have 24 x raised to power 3. And that leads us to the past question that we have here. Let's look at what we have here. Okay, we are given the function y equals to x raised to power 2 minus 12x plus 7. We have to find the dy dx, and we should solve it when x equals 5. So what we need to do here is we are going to be employing the formula dy dx, which is a n x raised to power n minus 1, and we solve this. Okay, now for this one now, we have the y over the x equals to a n x raised to power n minus 1. So from here, we are going to be picking the coefficient of this question one after the other. So for the first one, we have the y over the s. Okay, now this one, the coefficient we have it to be what? Which is y is what here? Y is 3x squared minus 12 plus 7. So we are going to be picking this expression and be differentiating it one after the other. So the very first time, a is going to be what? A is 3 and n is 2. So we are going to be having 3 multiplied by 2, x 2 minus 1. Now for the second one here, we have a coefficient of x here. The coefficient of x here is 1 and a is what? 12. So we have 12 multiplied by 1, x 1 minus 1. And for this one, the coefficient is what? The coefficient of x is 0. And anything multiplied by 0 will give us 0. So our answer here is going to be 0. Now we have 3 times 2 will give us 6. 2 minus 1, that is 1. So we have x raised to power 1, so which is x minus 12 times 1 is 12, right? 1 minus 1 is 0. Under indices, anything raised to power 0 will give us what? 1. So x raised to power 0 will give us 1 here, and this is 0. So for this now, the y dx is going to be 6x minus 12. Having that, they told us that when x equals to 5. So that implies that in this expression here, wherever we see x now, we are replacing it with 5. So we have it to be 6 multiplied by 5 minus 12. What is 6 multiplied by 5? That is what? That is 30. 30 minus 12 is what? Is 18. And that's the solution to this equation. Now, this leads us to the end of our class. We want you to subscribe to our channel, www.edubbey.com, for the full interactive content of this class. Thank you.